Hey everybody, this is Jonathan at Quixel. Today I have two special friends of mine, Jack McKelvie and Joseph Downer, both artists and technical artists here at Quixel. And oddly enough, or surprisingly enough, this is the first stream of the year. So welcome to 2020, everyone. Only 24 days late. Hope you all had a great New Year's, great winter holidays. I know we all did here. Today, we are going to be working on discussing how to blend Megascans assets in Unreal Engine using some pretty advanced techniques, and you guys should be able to easily follow along. So, whenever you are ready, gentlemen, please begin.
All right, let's go ahead and kick it off. If you've already read the article, you know that we are going to talk about world-aligned texturing, pixel depth offset, distance field mesh blending, and runtime virtual texturing. And these are all in relation to blending assets with the terrain. And in some of these cases, we can blend these assets with other assets that have the same material on them or other setups that kind of match it. But for this tutorial and this stream, we're going to focus mainly on blending the craters here with the terrain. Let me just get to a better position here. So the first thing I'd like to go over is the world-aligned texturing. World-aligned texturing has been around for a long time, and it's been used in a lot of different games because it's pretty cheap. It's not too hard to implement. For the most part, it's been the go-to solution for a long time. The only issue with it is it doesn't get rid of lighting seams. But let's go ahead and start breaking this down. Let me first grab all of our craters. Oops. I'm just going to go ahead and apply my world align material to that, and so we can kind of see what's going on. All right, so as you can see here, the texturing all lines up really well. So it tiles across the crater surface and the terrain. But when we kind of get over to this position, you can kind of see this nasty lighting seam, and that's kind of what we've been dealing with for a long time. Is we can get the tiling to match up, but the lighting seam's still there. Let's go ahead and take a look at the material that I have going on here. This is the crater material. And what I'm doing here is I'm taking a vector 4 parameter. Basically, if you just create a vector 3 and then convert that to a parameter, it'll automatically change that to a vector 4. So in order to get that back to a vector 3, I'm just creating a component mask here. And you can find it just by searching component mask and making sure all 3 channels are checked. And now this gets looped into a world-aligned texture node, and this comes default with Unreal Engine. This is a material function that allows us to project on some different axes here. For this material function, we can actually output several different channels here. We have the Z texture, and typically this is what I use the most often. That's just going to project our texture directly down from the top direction. So if you're in the editor looking straight down, that's what it's going to look like. So we're going to get that kind of projection. And now if you wanted to do some sort of triplanar projection, or say if you have some vertical cliffs that you want to project some Megascans textures onto, and like you don't want to sculpt it and bake it out, you just want a tiling texture on that, XY can work really well because that's only going to be let's see if I can rotate this. Yeah, so this here shows a pretty good example of it. It's going to be in the left, right, front, forward direction. And alternatively, you can also do full-blown triplanar projection, which is XYZ texturing. That's going to be really expensive, and you probably should not use that unless you absolutely have to, or if you know you can actually afford to use that, or portfolio environments, that kind of thing, it's totally okay. But generally speaking, I like to stick to the Z texture because that is the cheapest. And then I do that for each of these textures. So I have the albedo, I have the roughness, I have the normal and displacement. And the only thing going on here with displacement is just I did a little math here to make sure that it is pushing and pulling the vertices instead of just pushing the vertices. Now let's go ahead and take a look at the world align, another way to handle world align texturing. This is another way to do it, and it's a lot cheaper than what I just showed. All I'm doing here is I'm taking the absolute world position, and I'm taking the taking a component mask and masking the red and green channel, and that is actually giving me my UVs. And then I'm dividing that by a constant value. So what this is doing is it's allowing me to tile this in world space. And as you can see here, you can actually see a nice preview of this, how it's moving around in world space. But basically, what that's doing is it's allowing us to have that same effect of tiling world space, but much, much more cheaply. Like if I compare the original shader, if it loads up the instruction count, perhaps, there we go. We're looking at 158 instructions here and 130 instructions here. So it's quite a bit cheaper to do this instead. Unfortunately, this doesn't have quite as many of the nice features that this node has, but if you want to do it cheaply, that's a good option. All right, let's go ahead and move on to pixel depth offset. All right, let me go ahead and grab my craters again and add pixel depth offset. Now the thing with pixel depth offset is it's a nice little feature, but it does have some downsides. For pixel depth offset, we need to disable static. No, hold on. Let's search it. Yes, cast shadows. So we need to disable shadow casting on these in order for it to look correct. If I open up the material, well, I can go ahead and show you all what it looks like when we have shadows enabled. So if I come over here and just re-enable these guys, cast shadow, and if I start cranking this value up, what you're going to notice is a lot of shadowing artifacts. That's obviously not what we want. That looks really awful. But if we disable shadow casting, you know, it starts to look a bit more correct, albeit, you know, it's blending a little too much there. So let's go ahead and change that back to something like 20 or 50. So the way we set up pixel depth offset is we can take our previous material, which had the world aligned texture setup. That way our textures are still matching and still tiling across both our craters and our terrain material properly. Although we can just add this little section called pixel depth offset, and all we have to do is we have to add a dither temporal AA node and multiply that by a constant value, and then we're just going to route that into our pixel depth offset input here, and that's going to allow us to dither our intersections wherever this mesh intersects with the terrain or some sort of other object. It's going to start dithering around that edge. And you can see that effect here. So if I just set it back to 0, that's what our original world aligned texture setup looks like. And if I just start cranking that up, 10, 20, 50, we start to see a more natural blend where we don't quite see that nasty lighting seam anymore. All right, Jonathan, do we have any questions?
So far, not yet. Just
All
a lot
right.
of chatter, people talking, engaging, chatting,
Very cool.
having fun.
Very cool. Just making sure. And Joseph, would you like to explain this any further and more in depth, or?
I think you've covered it. There's no point in getting super technical with what pixel depth offset is doing.
All right, cool. Well, with that out of the way, let's move into the more complex distance field blending. This is going to take a little while to cover. It's a very complicated technique, and I want to make sure that we have it all covered. So first thing that we need to do is grab all of our craters again. And let's get the cast shadow back on. And the thing with distance field blending is we need to make sure that we disable this little feature here. Affect distance field lighting. We need to make sure this is disabled. Otherwise, it's going to sample its own distance field and the whole thing will turn out really blurry. So just make sure that whatever object you are blending with your terrain, make sure that has affect distance field lighting turned off. All right. Let's pop this open and apply that guy. All right. All right. So as you can see here, let me just display what's happening real quick. All right. So right here we have blend distance, and I will go over everything, how everything's happening here. But basically what this is doing is it's taking the intersections, wherever this mesh intersects with something, it's going to blur the normals, and it's going to try and average those normals against the other surface. So if I just set this to 0, again, that's what our world aligned texturing looks like. And so if I just start cranking that value up, it starts to blend and look a bit more realistic with the surface. The downside to this is you do need to have basically this texture setup exactly the same as the terrain. So it needs to be replicated from the terrain over here. And if you have like grass or something like that painted there, there's still going to be a harsh intersection because it will not automatically update. So it's a bit of manual work to get this going. Let's see. So let's go ahead and break into how we're sampling this and how we're actually doing this. So right here we have our normal, and this is just pretty average stuff. I'm just routing our world aligned texture into a flattened normal, and so I can adjust the normal strength. From here, what we need to do is we actually need to transform the tangent space data, this is a tangent space texture. So we need to change that to a world space texture basically. And we're going to route that into the B node. And right here, what we're doing is we're actually getting the distance field gradient and turning that into basically a normal map. So that's what's being basically plastered on right here along this seam is the distance field gradient that is normalized. So that's getting placed right here. That's our blurred normals basically. Now to blend these, and so we can actually sample where mesh intersections are actually happening, we need to use a distance to nearest surface node and divide that by our blend distance. So this is actually what I was messing with earlier that controlled the fall off. And then I'm just clamping this to a 0 to 1 value. And that is what's driving our alpha. So it's not terribly complex, but it is very expensive. As you can see here, the shader instructions is about like 3 or 4 times as much as just plain world aligned texturing. So this is definitely a very expensive method to actually get this working. And of course, since we transformed this into world space and this is all world space, what I have done here is I'm transforming that back into tangent space and plugging that into our normal input. And that is what gives us our final result. And Jonathan, do we have any questions regarding distance field blending?
No, but people are super excited to discuss virtual texturing.
I'm sure they are, because virtual texturing has tons and tons and tons of potential for all kinds of different things. We're very excited to talk about it too.
Don't worry, guys. We'll get there.
Yes, we will. Yes, we will. I'm just gonna double check with Joseph. Is there anything else I should be explaining here? Would you like to kind of explain anything further?
Not with this one. We'll talk some more on virtual texturing whenever we get to it.
Okay.
I think we spent enough time on distance fields.
Okay, cool. Sounds good. As you can tell, we're very excited about virtual texturing. There's a few issues with it, but we're very excited to actually talk more in depth about this. Due to some technical problems, I actually had to separate out the project to something else. So bear with me as I get my bearings again. Let me make sure everything's loaded. Looks kind of odd. Well, as you can tell, there's some bugs, there's some issues, but we'll break into this now. So with runtime virtual texturing, the first thing that we have to do is we just need to enable this in the project settings. Similarly, if you're going to use distance field blending, you need to enable distance fields. So generate mesh distance fields, that needs to be enabled if you're doing the distance field technique. And we need to enable virtual texture support if we want to use RVTs as well. All right, so one of the first things that we're going to want to do is to set up RVTs. You just want to right click and navigate to materials and textures, and then just create a runtime virtual texture. And that should look something along the lines of this right here. And from there, what we need to do is we need to actually create a volume, and I actually have a volume here in the level, but you can find the runtime virtual texture volume right here. And the nice thing about that is they have a lot of little tricks here to make it actually pretty easy. I'm actually going to delete that. So what you would do is you would just drag and drop your RVT right here into the virtual texture slot. And then just click this eyedropper, and you're going to select whatever your terrain component is. And from there, all you have to do is copy rotation, copy bounds, and what that'll do is that will make this volume encompass your entire terrain. If you wanted to somehow encompass more, or if you wanted to kind of be smaller, you can scale it afterwards, but that is all that's necessary to get that part set up. All right, so the next thing that we need to do is we're just going to click on our terrain component here, and right down here in the virtual texture section, just hit this little plus button, and we're going to plug in the same RVT that we had as before, and that's just going to go right here. Now we can finally get into our material setups. So let me go ahead and open up our terrain material. All right, so there's nothing too special going on here. These are all the different layer blends that are just plugging into my typical make material attributes for our terrain. So this is our albedo, roughness, normal, etc. And so from here, what I've done is I've routed this into a virtual texture feature switch. And this just allows a little bit more control. And what we can do from here is just run a runtime virtual texture sample into a make material attributes, plug that into our yes. What this is going to do is it's actually going to allow us to sample our own terrain here. So by adding a runtime virtual texture output, this is taking all of our data here and outputting that to the terrain, which is outputting it to our RVT texture. I hope that explanation makes sense. And Joseph, feel free to jump in anytime if you want to explain this in a more technically sound way.
No, right now you've got it. There's
Cool.
nothing more to explain. You just need to. There are two different nodes because your materials are communicating. The landscape needs to output the RVT details, and then whatever objects are going to be reading from it will need to sample from that output. So you've got it so far.
Okay, cool. Thank you. Okay, with that in mind, let's go ahead and jump over to our creator material. Let me find it real quick. RVT, there we go. All right. So this is where we can get a little bit more fancy, a bit more custom with our stuff, because all we have to do is we just need to add our runtime virtual texture sample here, and then we can plug in our RVT node. And you'll notice there's this little virtual texture content slot here. Basically, you can just choose to only use base color, which is going to be a lot cheaper. You have all these options here, and you also have world height, which is separated out from this. So if you want to sample the world height, you'd have to bring it in separately. And from what I understand, landscape tessellation does work for some people, but I was facing a totally broken bug, and I submitted some requests to get it fixed. So it's sort of in this rough state where tessellation maybe kind of works, but not quite. So I think we're working on, or Epic's working on some fixes on that in the meantime. But look out for that, basically, because once that arrives, I'm going to be very excited about experimenting with this technique in all sorts of different ways. So what I'm doing here to blend everything is I'm using the runtime virtual texture sample node, and basically I'm taking the world height and I'm using the world position and masking the B. So basically the Z height, I'm subtracting the world height from that. And then I'm just plugging this into some parameters that allow me to control the kind of fall off from when it intersects with the terrain. There's going to be some level of fall off, and I want to have some controls there in order to tighten the gradient or potentially make the gradient larger, all those kinds of deals. And once this is done, I am plugging this into the alpha for each of these lerp nodes. And that is what is allowing me to blend between the original texture set and the terrain texture set. So hypothetically, I didn't do this with these craters, but this could be a totally different material. This could be a grass material, and routing these into these lerp nodes, that would allow whatever terrain layer is being painted, that's going to show up wherever the craters are intersecting with the terrain. So I can kind of show how that works here. Hopefully everything will work kindly. Oh, there we go. It fixed itself. So if I just start painting here, you can see, oh, grass shows up on the terrain and the crater. So it's a very nice feature that has a ton of applications for it. And let's see. Yeah, okay. So Jonathan, once again, do we have any questions regarding RVTs yet?
No, but we are having plenty of questions about virtual texturing, my friend.
Okay, shoot.
Mostly people just want to know what it actually is. But as I keep saying in chat, we will get there soon. So hang on, guys. We are getting there.
Okay, so basically, virtual texturing from my understanding, maybe Joseph would actually be better at explaining this, but virtual texturing is a little bit different than runtime virtual textures. Virtual texturing is a way to, it's sort of like mega texturing that IdTech was working on, where you only need to load in a certain level of detail based on the screen space resolution. So basically you can tell a texture like, be at this resolution for this resolution on your monitor, and then it should basically fade out in distance. So runtime virtual textures is a little bit different. It's more of like a way to communicate between different materials than anything else, because basically we have this, it's sort of like I want to say it's almost more like render targets. But,
That's right.
Okay, so yeah, Joseph, feel free to add in anything you like there, because I'm not the best at explaining the super technical stuff.
It's basically a procedural render target that's generated on the GPU, and you can communicate between materials, like you said. There's a lot of really interesting applications that come with it. We're going to show some of those at the end of the stream after we're done with this. But one thing that's really great that Jack mentioned is that you can read tons of different objects into the render target. So say we have a terrain and we have these craters and even the rocks. As long as you have any sort of output node or sample node in those materials, any material you bring in can sample from the terrain. So unlike distance fields, to where you have to manually set up everything and it requires a lot of work, you don't have to do that here, since it's all procedural on the GPU.
Right.
It's very fast.
Yeah, so basically what that means is there's actually a lot of applications for this that we can utilize. Like, it's not just asset blending or whatever. Like, for example, if we wanted to sample the terrain layers, and then say if we wanted to add this to our grass material, we could add this into our grass, and then as we're painting our terrain layers, we can actually route our base color and adjust the grass color tint based on the layers of the terrain. So for example, if like these craters were like really scorched or something, and I had grass like painted all around, inside, stuff like that, where I've painted the scorched material layer, it can change the grass color automatically. And a lot of the exciting stuff, for me at least, regarding runtime virtual texture sampling, is just how everything is handled automatically. You don't need to do all this manual setup of copying the world-aligned texture setup from the terrain and the crater. You can actually have a totally different tiling setup here, and it will still blend correctly, and it'll still work, which to me is very exciting, because doing all this stuff manually, it takes so much time, it takes a lot of effort, and it takes a lot of dedication to make sure you're doing that for everything. And sometimes performance-wise, you're just not able to do that. So having one thing kind of handle it all, that to me, that's one of the really cool things about RVTs.
Definitely.
Gentlemen, I have a question for you from chat.
Yes.
Exile Mod would like to know if there's a reason why we're not blending with world space normals.
We actually, I don't know if you mentioned that you need to disable tangent space normals, not material.
Yeah, I actually did not mention that. Thank you for bringing that up. But in the creator material here, I actually had to disable tangent space normals. So if I actually enable that and just apply that again, you'll notice it doesn't look correct.
So you were doing it the right way the entire time.
Yes.
You could say that. So yeah, with tangent space enabled, we still have the lighting seam issue. With it disabled, No more seams. Once it loads, apologies for the long shader compiles, but as you notice, the seam is much less noticeable now. The only reason why it is still noticeable is we have we still have that harsh change in direction here. Once displacement is actually enabled, that's gonna pretty much go away. And this is actually a lot cheaper than distance field blending as well. If you notice, the shader instructions is kind of high, but with a lot of optimizations, like getting rid of the world align texture setup, just doing a really basic setup here would actually reduce that shader count quite a bit. So yeah, it's a pretty performant option that works pretty well. All right. Just looking at what we should talk about next.
Distance fields is what we just covered, yes?
Yes, distance fields is what we just covered.
Gentlemen, I believe it is now time to talk about runtime virtual texturing.
Well, we have been.
Yeah, we have been.
Well,
well, what we can do is, since we do have a little bit more time than I anticipated, what we can do is we can actually go into the grass texture, and I can kind of show how that would work, because then, like I said before, with runtime virtual texturing, the really nice thing about this whole setup is just how flexible it is and how many different applications it has. It's kind of endless. I'm excited to see where people start taking this, because people always take this in weird directions, and it's always very exciting. So let's go ahead and just look at our grass material.
Before you get too in-depth with that, I have a pretty good question from Tural Memedov.
Shoot.
He would like to know that if he has an expensive terrain material with distance fields blending, then can he sample or convert that shader to RVT and get a cheaper version of the same shader?
Yeah, so I mean, basically the all of the expensive part is coming from the crater itself, because that's where all of the distance field math is happening. So all you'd really have to do is swap that out with RVTs, and it would be quite a bit cheaper. The distance field blending technique is pretty expensive. I'm running a machine that's pretty average. It has a GTX 1070. I have like 32 gigs of RAM and just a kind of an older i7 CPU. And I notice a pretty significant hit whenever I enable the distance field blending. So yeah, and I obviously don't notice that with the RVTs. And a big part of that is just how much cheaper the shader is. With some displacement, it would be a bit more expensive, but RVTs is definitely, in my opinion, the way to go moving forward with new engine iterations.
Once displacement works for it, I don't see anybody really needing distance field mesh blending. It's prohibitively expensive. And
I agree, yeah.
It doesn't have as many applications, and the manual setup is just too much.
I totally agree. And again, that's the big part, is just like how easy RVTs are to set up. And once you get them set up, everything is handled automatically. And so it gives you so much more creative control over how natural and how detailed your environments look. And it removes a lot of the barriers in front of you with other blending techniques. You don't have to copy and paste setups. You don't have to do all that stuff. It's very straightforward, very easy to implement.
So, another question. Exile Mod would like to know if we could perhaps show RVT decals or grass coloring or potentially road splines.
I sent Jack a video of the grass coloring RVT.
Yeah, let's go ahead and open it up now. Joseph here came up with a really nice example just for pitching this whole idea, and it looks really cool. So there you can see he's painting a green layer, and then he's painting a dirt layer, and it's changing the color of the grass. Yeah. So there's a lot of really good applications for this. Like the grass is really nice, and like they mentioned, RVT decals are really cool. I haven't had a chance to look into RVT decals yet, but the potential here is just really crazy. All right, let's while we're waiting on fielding more questions, or if Joseph wants to explain a bit more, I'm going to kind of look at just copying this setup over and just applying it to the grass real quick.
I've been seeing some questions in the chat about kind of copying materials and how, like you would with distance field, and if you need to do that with RVTs. So I kind of figured I would explain a little bit about how this technology works. So basically, if you can imagine, you have a camera at the very top of your level projecting straight down onto your terrain. The camera would basically sample the terrain's color, normal, displacement with world height and everything like that, and you would have access to it. And you need to keep in mind that it is a projection. So if you tried to sample an RVT texture in something that had verticality to it, it will produce stretching. So you need to keep that in mind. So with the grass and with the terrain, basically what you have is you're not sampling individual landscape layer weights. So if you're painting your different layers, you don't have access to that data. It is just capturing a picture of your color and normals and things like that. So that's what you have to work with. So if you have your sample, you don't need to copy any setups. You just have that one sample, and then you plug it into your object materials, and you're good to go.
That being said, we do have another question, if you guys would like to answer.
Yeah, shoot.
First and foremost, what are the specs of the workstation that you're using?
I mentioned it before. It's really nothing special. I have a GTX 1070. It's not like a Founders Edition or anything. It's just very basic. I have an i7 6700K, I believe. I do have 32 gigs of RAM. I'm also running everything off of an SSD, and that's pretty much it.
All right. The next question after that would be, can we automate the virtual texturing density and transformation when you're blending with certain textures?
Can you repeat the question?
Can you automate the virtual texturing density and transformation when you blend with certain textures?
I would think so. Again, maybe Joseph would be better at answering this question, but I think all you'd have to do is put some sort of power node down with, like if you wanted to control fall off, if that's kind of your question, all you'd have to do here is on this saturate node, just plug a power node into that, and that should start controlling your fall off. But again, you have a lot of different options here. Like what I did here is I found just having an add here to control the bias, and then the length controls the blend length, so the gradients length. I found that to be enough to control how things fall off.
All right.
Fell off, I guess.
A couple more questions as they continue rolling in. PJ wants to know if we can provide a sample file with things set up correctly. He's not sure if he can figure this out, trying to build it from scratch.
Our article has download links to all of the materials that we're covering today.
Yes,
kind of figured that this would be an issue for people.
Yeah, this stuff is super complex. So we did provide links for all the different materials. So distance field blending, RVTs, world line texturing, and pixel depth offset. You can find everything on the article.
I was going to say it's an issue for me, and I've been using Unreal Engine since 2008. So
this is complicated stuff. I've been working on figuring out like a good solution for this for a long time. I know there's like polycount articles out there that are years old that started back in like 2014 trying to solve this issue, and I'm actually just really glad that we could actually get the opportunity to put out a lot of this into one place.
Oh yeah, absolutely. So for the second question, XL Mod would like to know if we're going to cover anti-stretching techniques for the landscape surface. He found that the surface normal Z to be useful, but if you know of any other projection methods, that would be helpful as well.
Well, there is other projection methods, as I mentioned. Let me just pull this back up. Okay, so to basically get rid of that, a lot of what a lot of people do is they use XYZ texture here, and that's just triplanar texturing. So whenever that stretching happens, basically it's going to start transitioning to a Y or X projection. But like I mentioned before earlier in the stream, triplanar texturing or XYZ texturing, that is very expensive, and I don't think I could recommend doing that on a terrain unless you only have like one of these. So if you wanted to, say if you wanted to automatically have rock on like really sharp angle surfaces, so as you know it gets really steep, it's going to display rock, then you could do like an XY texture. That way, you know, whenever it's super steep like that, you have rock coming in and projecting on the XY axis. But if you wanted to do that on everything, that is probably going to absolutely murder your performance.
It's really not great, especially because a lot of people see complicated landscape materials and they end up implementing distance-based tiling, which is really bad whenever you combine it with triplanar texturing because you have multiple samples for every single layer. So the more you add, the worse it gets.
Oh yeah, I didn't even think about that, but especially like you said, especially with the distance and changing the tiling at a certain distance, you're talking about like doubling the amount of samples for that.
It's insane.
Yeah, no, that would be. You'd be lucky to get any sort of good performance out of that.
Well, so far the questions seem to have mostly dried up. So, actually, we have one more that might tie into what you guys just said. Taral Mehmedov would like to know if it's possibly off topic, but we can see if we can answer it anyway. Can you blend detail textures based on camera distance with RVT?
Yes, you can. There is a specific node for it, and I don't remember what it is at the moment.
Let's find it.
Fat load of good you are then, huh?
Runtime.
I kid.
Yeah. You don't do it the normal method will not work. There is a very specific node to get this to run.
Oh, really?
Yeah.
Do you have any idea what it's called?
No, I don't. I saw it like 2 months ago.
So close. Okay, well, it is what it is.
We'll get back to you on that one.
Yeah.
You can do it. We just don't know how. All right, so I'm going to just jump back into this real quick because I think this would be good enough to show. I can actually find... there we go.
So another question coming in from KD. Could you guys elaborate more on tiling issues with terrain materials?
Tiling issues?
That's very vague.
Yeah, could you be more specific? Like what kind of tiling issues? Like stretching or...
Let's assume stretching for the moment.
Okay. Well, like I said, probably the best way to handle it is XYZ texturing or triplanar texturing, but again, it's not very performance friendly, so it's not super realistic. Of course, there's one way of handling it, and that is, avoid sharp angles like this. Like you'll notice I do have some stretching here. It sort of works for my example because it sort of makes sense. An explosion happens and stuff's like ripping out of the crater, so it's passable. But generally, if I wanted to get rid of that, I would have really rounded out this edge a lot in order to avoid this kind of stretching. Excuse me. I think of another option. Another option you could do, I suppose you could blend, if you wanted to, you could blend between different techniques. So if you wanted to do world-aligned texturing just along this edge and then have the rest be based on UVs, you could use vertex coloring to blend between the different options. So you could have basically, say if you wanted to use the red channel, you could actually set up this edge to be red and the rest to be basically black in the red channel. And what that would allow you to do is you could blend between the world-aligned texturing and then have the rest be based on the UVs. And that would effectively get rid of any stretching that you have.
So I completely misinterpreted what he said. It was actually about how to get rid of tiling, or at least visible repetition.
Repetition, okay.
There's a few ways to do it, but they're very complicated. A lot of it will be hidden anyway once you have proper set dressing. And you can have layers of noise over whatever you're trying to hide. And after that, you start getting into stochastic tiling and texture bombing to hide repetition, which is not in the scope of this video.
Yeah, I agree. I think there are quite a few ways of handling it. In my opinion, the best way is just the traditional way of distance-based tiling adjustments. So basically, if I'm in the beginning of in the front of my scene, I'm going to have really up close detailed tiling, and then as it gets further away from the camera, it's going to transition to a larger tiling. So it's going to look a little bit more, a little bit larger, a little bit less detailed, but you won't see a lot of that tiling and repetition out here. That's probably the best way in my opinion, especially when you start scattering assets like this all around. It tends to cover up a lot of the tiling. If you don't have the ability to place a lot of those assets, then you should probably invest a bit more time into the material itself. And like I said, have those kind of distance blends. You don't want to do that too many times because you're calling each texture set twice if you're just doing it one time, and then if you do it again you're calling all those textures again, so that can get a bit expensive. But usually just having one blend in the foreground and background is enough to do the trick.
Yeah, it's a tried and true technique. It works really well. A lot of people need to realize though that with texture tiling, a lot of that is inside your actual texture. A lot of people like to add really unique details, but don't realize that the more you do that, the more visible your tiling is going to be.
Very true. Very true. I think a really important thing to do is when you're making your tiling textures, take it into Marmoset or something and just have it tile a few times. And then you'll start to notice what details are acceptable and what details make it really obvious that you're tiling. And then you just need to get rid of all those things that make it look obvious, and that will help a lot in making it a lot more visually less repetitive.
Or if you're working in Quixel Mixer like you should be, press the T button. That way you can see it tile.
The easiest method.
I have a question.
Yeah.
Who comes up with terms like texture bombing? Because to me, that conjures up a B-52 flying over some country, dropping a bunch of bricks. And I'm just trying to figure out who comes up with these names. Because I looked it up on Google, and I'm I don't even want to pretend I understand what they're talking about until I deep dive into it.
Mm-hmm.
No, they're very advanced techniques. Texture bombing is actually really good for getting rid of texture repetition, but it's expensive. There's actually a node for it in Unreal if you want to play around with it.
Is it actually called texture
Really?
bombing?
Yes.
Really?
Yes. Yeah. My favorite
my
method
God, you're
is
right.
stochastic tiling. You can basically think of that as randomized tiling, but it's pretty. It's kind of in the weeds to implement. It's pretty complicated.
Gotcha.
All right, guys, back on topic here. XL Mod wants to know if there's a reason why your terrain material is two-sided, Jack.
Two-sided. No reason. I don't even remember why it's two-sided. I think I was doing some testing because when I initially started testing out this technique, there was a lot of issues on my machine. I don't know if it was my version of Unreal or what, but I was having a lot of technical issues. Mainly, I was trying to have tessellation enabled on everything, and that was causing hard crashes. So I was like, okay, so I need to figure out like why this is not working and why it keeps crashing. So I was just messing around in here trying to figure out literally anything that would work. So
Click all the buttons.
yeah, click all the buttons and see what comes back without a crash. And with my machine doing those shader compiles every time and then crashing, I was pulling my figurative hair out.
Oh, that sounds awful. Let's see. King Axel wants to know if we can explain how the landscape material adds foliage on top of the material, and I can do that for him easily because that's something I know.
Okay, go ahead.
All you need to do is add the landscape grass node, I believe it's called. And you just plug that in. I'm sure you guys know more about it than I do off the top of my own head. But essentially inside of that node, you determine which actual layer is going to have a specific type of foliage added to it. So wherever you paint that layer, once Unreal recognizes that it's been done being painted, it then populates it with that particular type of foliage at the density that you've set it to.
Yep.
Yeah, that's correct. I was also going to mention, actually, now that you mention it, the that technique combined with RVTs would be very powerful, because then at that point you're painting foliage and all of the foliage is updating in real time based on the layers of your landscape. That'd be really nice.
You can do that anyway without RVTs, but yeah.
Let's see, guys. So we have 7 minutes left in the stream for today. Again, this is the first stream of 2020. It took us a little longer to get this set up, but this has been a very complex bit of streaming. Under the hood, you would not believe how much work these two gentlemen went through to get it ready for you. So really, let's open the floor up. If you guys have any questions, let us know. What we can answer, we'll answer. Things that are proprietary, we cannot answer, such as the question about what cameras we use for texturing at Quixel. That is proprietary. We cannot tell you. I am sorry.
Well, as questions are coming in, I just want to show this little test. So basically, setting up RVTs is literally this simple. All you have to do is you can lerp, you can multiply, whatever. The base color of the terrain is coming out of here, and I just want that to alter the color of the grass and foliage. So as I paint a different layer here, it should change colors, hopefully. Maybe a little bit, maybe it's not noticeable. So if I come back over here. Yeah, so you can kind of see it when I enable and disable it, how the dirt is actually changing the colors of the grass. So yeah, it's very simple setting up RVTs, and the potential here is insane. One of the things I was thinking about doing is like a water shader. One thing that would be really cool is like along a beach, if you wanted to paint a specific sand, you could actually alter, or you can actually have like waves crashing against the shore based on where you're painting that layer. So there's so many things that we can do with runtime virtual texturing. I'm very excited about it getting a little bit more stable not causing crashes on my machine, and it's got a lot of potential. All right.
Oh, we are getting flooded with questions. Give me a moment here.
All right.
Oh, he actually reposted it because I was going to go look for it. Timil Hackings wants to know, in this scene, it's movable, or is it movable lighting or static lighting, and which one is most suggested? I would like to take a stab at that, but you guys are the experts here, so go ahead.
Okay. Yeah, this is all dynamic lighting. For this project, I didn't have enough time. I mean, it was pretty much just a time thing. There's no way I would have enough time to basically swap out materials every time, rebake lighting, etc. Especially for this stream. You saw me replacing these materials and stuff like that. There's no way I could actually do this live if it wasn't dynamic lighting. That said, with dynamic lighting is great. Or not dynamic lighting. Bake lighting is amazing. It has all these really nice features that look really great, but if you're doing a large open environment like this, and especially with a ton of foliage, it's going to take forever to bake those light maps, forever to bake them. So it's just one of those things where it made more sense to do dynamic lighting, and since performance was not that bad, and for other reasons, it made more sense to go with dynamic lighting. And right now, dynamic lighting in Unreal Engine 4 is really good. Like, it's perfectly acceptable to use dynamic lighting with a few other lights in addition to get some fake bounce lighting, or if you want to alter your skylight to add a bit of like a bounce lighting, that usually does the trick for me. Like, if I look at this, I think I might have but I talked about this in the Blood Gulch stream a little, but this is a nice little thing that you can mess with. Just lower hemisphere is solid color. If you mess with that, sometimes it can look like it's adding bounce lighting. In this scene, it's not really doing much. I'm not really sure why, but in a lot of scenes, messing with this and changing the color can make it look more like baked lighting, I guess.
And to echo in on your point there, Jack, pretty much everything that I make, especially if I'm streaming it for any purposes, is always going to be dynamic, because the second you change anything in a static environment, the light maps break.
Mm-hmm. Yep.
As we've seen, because we did a stream with you where that exact thing happened.
Yes, exactly. My alleyway scene had tons of issues regarding the stream and just updating it, and I kind of learned my lesson there where, yes, the quality does look amazing, but if you have to interact with it or if you have to make changes, it can be a nightmare.
Oh yeah, and I mean, it's not feasible to render light maps in real time at the moment, especially when we're trying to have discussions with an audience and whatnot. So it's always better for us, from our perspective, maybe the few frames of, the few frames of it's really weird to say, the frame rates you lose is a better way to put that, in order to run this dynamically, is worth the trade-off to actually have an interactive real-time discussion, because you wouldn't even be able to understand what Jack was saying because his voice would be robotic from the CPU trying to struggle with rendering light maps while he talks.
Exactly.
And if he sounds awful, the rest of us are too, because there's no way for his desktop audio to keep up with us.
No.
So essentially, that's dynamic is the way to go for what we do mostly. If you're just doing personal work and you don't need to make this optimized for real-time work, literally just throw it in there and crank everything up as much as you can. There's no reason not to, unless you just hate working kind of slowly, but there's ways to get around that. I find it very helpful to lay down foliage, and then when I put too much of it down and I need to focus on one spot, like maybe painting terrain or sculpting it, I will hide the foliage layer and get all that frame rate back, and then work on it, and then unhide the foliage right after I'm done. It also helps if you need to free up some frames to use unlit mode by pressing Alt-3 in the editor. That can also help you gain 20, 30, sometimes 60 frames per second just by taking away all of the post-processing that the engine uses. So it is now 2 o'clock Eastern time, guys, which means our stream is now coming to a close. I apologize that we couldn't get to everybody's questions. It was quite overwhelming. It's very good to see how much excitement you guys have for the work that we do here. And as always, it's very humbling that we're able to even work with you and help you guys learn as much as we're always trying to learn ourselves. As you can see, we don't know everything. Like, we couldn't field that one question about the detail texture that we just didn't know the name of the node for. But, we got most things covered, and I think we set out to do what we wanted to do. So, again, thanks for showing up for the first stream of 2020. And we have so many more coming. We're going to try to keep them coming every week, like we did last year, every Friday, if possible. As always, we'll keep you guys in the know. As many of you noticed, we did send out an email today. We're trying to be a little bit more communicative when it comes to this. So if you guys have any suggestions, please feel free to drop them in the Quixel art community, which, if you're not part of it yet, please join up. It is facebook.com/groups/Quixel Tools Group. Feel free to join, post about art, ask questions about streams. We'll do whatever we can to help you guys out. Ultimately, we do everything we're doing here for you guys. So, let us know how we're doing. And it is great to be here. And thanks, Jack. Thanks, Joseph. Both of you guys are outstanding. It is a real honor to have a stream with you guys, especially with how much stuff we covered. It's crazy. I can't even pretend to understand half of this. I'll have to dig into it. But yeah, thanks for having us on, guys. Thanks for seeing you guys, and we will see you next time.